Okay, Bismillahirrahmanirrahim. This is our first subtopic for chapter 4, which is exponential functions. Okay, first you have to know how to recognize the exponential functions. Okay, the function given, let's say fx is equal to a power of x, with your a we call as the base, and the power of the base is the unknown value, which is x value. So if you have this form, we call this one as exponential functions. And your base a must be always more than 0, and then your a cannot be 1, because when your a is 1 power of something, you will have 1 only, which is the constant. So that one is not considered exponential function. Example, let's say you have fx equivalent to 2 power of x. This is exponential function with base 2. Another example, 3 power of x, base 3, and then the last one, 10 power of x is the base 10. Okay, this is how you recognize the exponential function equations. Okay, the first subtopic, you will have the graph of exponential functions. Okay, you have two basic graphs, which is the first one when your base a is more than 1. So if your base is more than 1, you will have increasing graph. Okay, and then the compulsory point, which is the crossing point, is always 0, 1. Okay, example here, let's say you have the equations of y equal to 2 power of x. Okay, so when your base is more than 1, example 2, so when your x is 0 here, 2 power of 0 is always 1. Any number power of 0 must be 1. So this is the compulsory point, which is the crossing point of y-axis, which is 0 and 1. Another two basic points will be 1a. Okay, so your point here is based on the base of the equation given. Let's say for this example, you have 2 power of x. So your point here will be 1 and 2. Okay, and the third point here will be negative 1 over a. So when you have this example just now, y equal to 2 power of x, so the point here will be negative 1 and 1 over 2. Alright, so this is the three basic points on the basic graph of exponential function when you have your a is more than 1. Okay, what happen when you have a is in between of 0 until 1, let's say 1 over 2, 1 over 3, and so on, you will have decreasing graph. Okay, and then the compulsory point is here also 0 and 1. And then example for this function, let's say you have the function of y equal to half power of x. Okay, half power of x. The crossing point is always 0, 1. And then the point here, 1a, let's say your a here is half, so the point here will be 1 and half. Okay, and then the third point here will be negative 1 over a. So if your a just now is half, 1 divided by half is 2. So the point here will be negative 1, 2. Okay, so the 2 point here is based on the base of your equations given. But the compulsory point is always 0, 1. So if you have this type of graph, your a is in between of 0 until 1, decreasing graph. If you have a more than 1, you will have increasing graph. Okay, the criteria of the function, the domain or the x values is all real numbers or negative infinity up until infinity, meaning that you have the graph along the x-axis. Okay, this one also the same. Along the x-axis, you have all the graph. And then the range is the y value. So if you notice, the graph is only at the positive side of y. Okay, so your range is starting from 0 up until infinity. But the 0 is excluded because your graph never touch the x-axis. Okay, and the last one, you will have the horizontal asymptote. Asymptote here means the line that your graph cannot cross or touch. Okay, so you will have horizontal asymptote, which is your x-axis here. meaning that this one we call as the line y equal to 0. This is the line of y equal to 0, the x-axis. So your graph here will never touch or cross the x-axis. So you will have these 3 points on the graph of exponential function. Okay. And then the third graph that you have to know is the natural exponential function graph. Okay. Natural exponential function here means your base of the exponent is e. E is stand for the exponential function. So if you press your calculator, your e value here will be equal to 2.718 something. Okay. So if you notice, this one is more than 1. That's why you have the same shape of increasing graph, like the first type just now. Okay, and the point, the 3 compulsory point, this is the crossing point, which is 0, 1, meaning that e power of 0 is always 1. Okay, and the point here, at first just now you have this one as 1a, so your a here will be exponential, which is e, so your point here will be 1e. Okay, e is for 2.718 values. And then the point here will be -1, 1 over e. So you just write as e when you have the natural exponential function graph. Okay. The shape of the graph still increasing, same like the first type just now. Alright. So you have to know about the basic graph. And then after this, you will combine several methods of transformation graph. This one you have to recall back chapter 2, which is transformation of graph. So when you have reflection, when you have stretch or compress, and then shifting to the right, to the left, shifting upward and downward. So all that you have to recall back to transform the graph of exponential function.